Hello, everyone, and welcome back now to part number three of chapter five. This one actually will be quite short, actually, even shorter, I guess, than 10, 15 minutes. It's going to be quite, because we'll just be talking about one last form of transport, which is called bulk transport. So we spoke about passive transport, active transport, and now we're going to go into more the bulk transport. So this kind of transport, as the name says, is kind of in bulk. So here you really use like this very large polar substances, basically, to be trafficked inside of the cell. And there's two ways basically you can traffic things, inside or outside. So hence endocytosis or exocytosis. So in Latin, endo means actually in, exo means out. So, hence endocytosis means inside the cell, and exocytosis actually means outside of the cell. So that's a nice way to remember these things. So within endocytosis, you have three things: phagopinocytosis, receptor-mediated endocytosis. And then basically we will going into more detail into what each one is. So I'll go first on with the first one, which is phagocytosis. Phagocytosis, phago means eating. So cytosis is cell, so it's eating of the cell. So the cell, what it does, it actually eats, its surroundings, so kind of these kind of substances. So the proper, let's say, definition will be cells take in particulate matter. So it's taking actually matter. An example for this is actually here in this case could be a whole bacterial cell can actually engulf the whole thing. So really a big, substance that's intaking it. That's phagocytosis. Then you have pinocytosis. Pinocytosis, you're actually taking liquid. And of course, in that liquid, you can actually have solutes, things, that are, let's say, dissolved in that aqueous solution. So phago is more of, matter. Pinocytosis is more of liquid. That's what basically the differences are between those two. Then you have something that's a bit more specific. These guys are unspecific. They'll basically eat quite a lot of random stuff, a lot of random matter or random basic liquids around. While here it's more specific because it's more receptor mediated endocytosis. And this is what it means is you have basically this receptors shown here, where you have the tail, which passes through the cell membrane. And basically in the tail, it actually kind of, associates with this kind of pits that are made up from clathrin. Clathrin are these little proteins right here, and they have a very actually important function here. So what happens, of course, your target molecule here will bind actually to your receptor. This will signal to the clathrin to be like, okay, now time to do our job. And what they do is they kind of envelope everything around and they just take it inside. So you suddenly get these kind of clathrin, coated vesicles because the clathrin is basically kind of pushing the cell membrane and trying to kind of take whatever is out inside in. So that's one thing, one way of, of endocytosis, very specific. And this actually, happens a lot with cholesterol. We have these LDL receptors, there's low density lipoprotein receptors, and these guys are actually very important in taking up cholesterol in and to be digested in the liver or be further processed. So there is actually a very famous disease called genetic disease familial hypercholesterolemia. So by the name you can already see it's a genetic disease. It's really runs among families, and basically what happens is that in this disease, the tail is actually kind of gone. Something happens to that tail. Either it's lacking or sometimes actually can be certain mutations in there, but most of the time it actually the whole tail lacks. So once let's say the cholesterol actually binds to the receptor, this tail is not there to tell the clathrin like, okay, time to uptake whatever is in there. So what happens is that cholesterol is not taken up, it's not processed, and it stays in your blood. And that is extremely dangerous because what happens with these is you've got babies who actually have insane amounts of cholesterol in their blood, and this can cause heart failure actually at a quite a young age. So you can already imagine having, a 1 year old having cholesterol of literally a 50-year-old massive obese person, in a baby. That can be detrimental. And believe it or not, actually, this disease is it has been found to be actually quite common, not super common, but it has been seen in a lot of families up in the north of Lebanon. I was once reading a case about this a couple of years ago, that for some reason we actually have these cases up in the north in Lebanon. Because again, this is more genetic. So the last thing is exocytosis. Exocytosis literally means, the removal of things from the cell. And these, of course, can be, things that the cell doesn't want or wants to be actually, you know, um, sorry, my laptop's just going a bit haywire. There you go. So this means more like, the cell is releasing stuff outside. And this can be, of course, hormones, neurotransmitters, digestive enzymes, and whatnot. And this, for example, I'll give you a good example of this. You have these immune cells called T cells, which you'll definitely will learn actually in immunology. And these T cells, what they do, they're quite very professional at actually killing tumor cells or actually bacteria or basically virally infected um, cells. So what they do is they actually go into your virally infected cell or tumor cell. They get super close and they release. So they go through excitosis. They release these transenzymes and perforins. These are molecules that what they will do is they will actually kill the infected or tumor cell. So that's one way how they can use actually excitosis. So again, this was it. Very simple, short, and sweet. Hope that chapter five has been, much easier. I've been trying to actually get all of your, comments and try to adapt them to into my videos. Have a great day.